The last video with a quick check, and you are going to find the slope and use that slope in one of the points in this point slope form. And so the slope was 1/2. I chose to use the point 2, -1, so we get y plus 1 equals 1/2 the quantity x minus 2. Distribute the 1/2 across the quantity and we get y plus 1 equals 1/2 x minus 1. Get the y by itself, subtract 1 from both sides, and the equation of the line in slope-intercept form is y equals 1/2 x minus 2. Okay, so now we're going to do the next page, page 100. And we're going to do example 13. So this time we're told to write a linear function with the given values, and they gave us 2 points, but they gave us the 2 points in function notation. So you know that f of -3 equals 1. That means when x is -3, y is 1. So this is the point -3, -1. And then f of -2 equals 4. So when x is -2, y is 4. So there's our 2 points. And I'm going to write we have to find the slope between those 2 points. So I'm going to write the formula for slope up here just to have it handy. M is equal to y2 minus y1 over x2 minus x1. That's the change in y, the rise, over the change in x, the run. Rise over run. So to find the slope between these 2 points, I've got m equals 4 minus -1. 4 minus -1 is 4 plus 1 over -2 minus -3. Subtracting a -3 is adding a 3. So my slope is 5 over 2 negatives, 3 positives is 1 positive. My slope is 5 over 1, or 5. So now I'm going to take that slope and take one of my points and substitute those values into the point slope form, which is y minus y1 equals m quantity x minus x1. I can pick whichever point I want. I'm going to choose to use -2, 4 since it has only one negative. So plugging in my x1, my y1, and my m, I get y minus y1, which is 4, equals m, which was 5, times x minus x1. x1 is -2. Subtracting -2 is the same as adding +2. So to get that into slope-intercept form, I need to distribute the 5. So it becomes y minus 4 equals 5x plus 10. And then add 4 to both sides. We get y equals 5x plus 14. So there is the equation of the line in slope-intercept form. The instructions said to write a linear function f, so I'm just going to replace the y with f of x. And we get f of x equals 5x plus 14. Okay, so now we're going to move down to number 19. So in exercises 19 and 20, tell whether the data in the table can be modeled by a linear equation. Explain. If possible, write a linear equation that represents y as a function of x. I need a little bit more space here. Okay. So I know it can be modeled by a linear equation if it has a constant rate of change. So we're going to check the rate of change between these points. I see from -3 to -1, the x is increasing by 2. From -1 to 0, that increases by 1. 0 to 1, that's increasing by 1. And 1 to 3, that's increasing by 2. Now my x's aren't increasing at the same rate, but let's check how the y's are increasing. So to go from negative 110 to negative 60, that's an increase of 50. From negative 60 to negative 35, that's an increase of 25. Negative 35 to negative 10, increase of 25. And negative 10 to 40, that's an increase of 50. So I need to check that between each of these points if the function is increasing at a constant rate. So I'm going to check the slope between each set of points. So between the first set of points, my slope m is, the change in y is 50 over the change in x, which is 2. That simplifies to 25 over 1. Between the second set of points, my change in y was 25 over a change in x of 1. So still constant. For my third and fourth points, my change in y was 25. Change in x was 1. And the final 2 points, change in y was 50. Change in x was 2, which simplifies to 25 over 1. So it is linear because we have a constant rate of change. I'm going to abbreviate that ROC. Okay, so we know we can model this with a linear function, and now we'll do it. So we have a slope, it's 25. M equals 25. And I've got lots of points to choose from. I'm going to choose to use this point right here because that has 0 in it. I know it'll make my calculations more straightforward. So using the point 0, 35, 0, negative 35, plugging this into point slope form, I get y minus negative 35, that's plus 35, equals m, which was 25, x minus 0. Well, x minus 0 is just x, so this simplifies to y plus 35 equals 25x. Subtract 35 from both sides to get the y by itself. We get y equals 25x minus 35. So we could have done that just by recognizing that we had the slope and there's our y-intercept. The y-intercept is when x is equal to 0. So let's look at number 20 and see if there's a constant rate of change, see if we can make a linear model for this relationship. So from negative 3 to negative 1, my x increases by 2. From negative 1 to 0, that's an increase of 1. 0 to 1, increase of 1. 1 to 3, increase of 2. So I see right here that to go from 18 to 8, that's a decrease of 10. And then to go from 8 to 62, that's an increase of 54. So between these 2 points, my slope is negative 10 over 1. Between these 2 points, my slope is 54. Oops, forgot my equal sign. My slope is 54 over 1. So this relationship is not linear. There's no constant rate of change.